Very good morning, students. Firstly, I heartily welcome you all to this Vijay Chetana PU College, Kuvempu Nagar, Mysore, run by Navodaya Foundation. First, I will introduce myself. I am Ramya K. I did my MSc in Chemistry. Now, today I am going to explain the important concepts of chemistry. As you all know, especially in 10th, it mainly contains 4 to 5 lessons. But when you enter to first year PUC, it's entirely different. It mainly contains more than 14 to 15 lessons. Here, what happened means, what are the major difference between 10th and the first year PUC means, in chemistry, you are going to study each and everything in detail. For example, in 10th, everything are very concise. For example, atom, matter, everything. For example, organic reactions. Everything is very short and it's not in detail. But in first year PUC, PU level, you are going to study each and every concept in detail. In this first year PUC, it mainly contains some, chemistry means 3 parts are there. Here, in this year, you are going to study majorly 3 important classes of chemistry. First one, Inorganic Chemistry. Inorganic Chemistry. Second one, Physical Chemistry. And finally, Organic Chemistry. See, why we have to study this chemistry? Chemistry is important for our life. Yes, the answer is yes. You know why? Without chemistry, we can't survive. Every day we are taking food. It's nothing but carbohydrates. Carbohydrates means carbon, hydrogen, oxygen. There also chemistry, elements, atoms. Every day you are wearing clothes. It's nothing but chemistry. Polymers, plastic. You are using piece of chalk. It's nothing but chemistry. Calcium carbonate. Everywhere chemistry. We are taking oxygen in order to breathe, respiration process. Oxygen means what? O2 is nothing but chemistry. Without chemistry, we can't survive. Here, chemistry we are broadly classified into 3 types. First one, Inorganic Chemistry. Second one, Physical Chemistry. And last but not the least, Organic Chemistry. Here, what is this Inorganic Chemistry? As you all know, acids, bases, these type of spaces, it will comes under inorganic. What about atom, structure of atom, elements classification? In 10th, you all come across these words. Classification of elements, Mendeleev. Means such type of bondings. For example, water, what type of bond is there? How water molecules will form? What are all the elements present? Such type of things we will discuss under Inorganic Chemistry. And Physical Chemistry. Physical Chemistry means laws. Laws means what? It governs certain things. You all know Newton's law. Like that, in chemistry also certain losses are there. And also states of matter. What is the states of matter? Means, as you all see in our daily life, solid, liquid, gas, everything is nothing but states of matter. These are all we discuss under one systematic way. under physical chemistry. Organic chemistry, the name itself indicates organic. The component mainly derived from organic species. It mainly contains carbon, hydrogen, oxygen, nitrogen. Mainly deals with the bunches of carbon, hydrogen. Organic means living. You know, once ant bite, it start itching. Why? Because due to the presence of formic acid. Formic acid is nothing but organic. You know vinegar. Nowadays they are using for food. It's nothing but organic chemistry. You know NaCl. It's very familiar word. Sodium chloride. We are using for food. Salt. Rock salt. We call it as rock salt. Table salt. It's nothing but inorganic chemistry. Why? Charges. Plus, minus. Means why this classification is important means without a classification we can't memorize each and everything in a systematic way. That's why classification is very, very important. And now in this session I am going to start the first lesson, some basic concepts of chemistry. Yes, you all know chemistry is very, very important for our daily life. What are all the basic concepts? What is this basic concepts? Basic means we should know that. Before enter to the chemistry, we should understand some terminologies and important words. What are all the basic things? For human beings, some basic important things are there, no? Food, air, cloth, shelter. These are all the basic needs. For chemistry also, some basic concepts are very, very important in order to understand the chemistry. You all know chemistry means periodic table. You know, 118 elements. Without a periodic table, nothing. It mainly contains so many elements. Means in chemistry, we are going to deal with we are going to play with the atoms. How our natures are surrounded with chemistry. Now, I am going to start this concept, some basic concepts of chemistry. See, first and foremost thing, you know matter. What is this matter? It's a basic definition. You all know. Matter means it's nothing but anything. Anything means anything which has mass and occupy some space. For example, I am giving. See, this is a piece of chalk means has its own mass and it occupies some space. Just assume it's one surrounding. Has its own mass. Without mass, how can I hold this? Has its own mass and it occupies some space. This is one space. Within this space, it occupies some space. This board has its own mass and it occupies some space. For example, living being has its own mass and they occupy some space. Means, what is the definition for matter? Matter means anything which contain mass and occupy certain space. Anything means which has its own mass and it should occupy some space. For that only we call it as matter. Then states of matter. What is the states of matter? Types. It's a very familiar word. It mainly contains 5 types of states of matter. As you all know, solid, liquid, gas, plasma, Bose-Einstein. Bose-Einstein is recently discovered one. But in this lesson, we have not touched the plasma state and Bose-Einstein state. We are going to deal with the solid, liquid and gas. States of matter. It mainly contains, it's important for us only, solid, liquid and gas. What is this solid? Solid means you all know the basic definition of solid. Atoms are compactly arranged. For example, I will show. See? Just assume these are all atoms of solid. Atoms of solids are tightly, compactly. What is this word tightly, compactly? See, without any space. The atoms are as much as possible, they are close enough. See, the atoms are close enough. Such type of arrangement we call it as solid. Orderly arranged. Here all the atoms are orderly arranged. What are the characteristics of solid? Has its own mass? Yes, solid has its own mass. Definite volume is there. Definite volume is yes. For example, take one stone as an example. Has its own mass. Own volume, shape is there. For every solid has its own shape. I am not going to precise this is the particular shape. It may be any shape, but has its own shape. Stone, rock, bench, everything has its own shape. And here atoms are very nearer. Intermolecular distances are 0. Intermolecular means what? Inter means between the one atom and the another atom. The space is very less. Why the space is very less? Because they are very close to each other. In solids. What about in liquids? Liquids, the atoms are arranged little bit far away from one another. This is regarding solid. This is regarding liquid. Mass is there. Volume is there, but no shape. How you come to know liquids has no shape? You know, you just take one water bottle. Just pour the water. It will take the shape of the water bottle. The same water you just transfer to one tumbler. It will take the shape of the tumbler. You just transfer the same water into the mug. It will take the shape of the mug. What it indicates? It does not have any shape. It will take the shape of the container. Container means in which way we are putting. Means where we are using that. Bottle, it will take bottle shape. Container, container shape. Mug, mug shape. Means it doesn't have particular shape. It will take the shape of the container. It resembles the shape of the container. What about the gas? This is gas. And liquid, one more important thing. It will always flow. You know, water will flow from upper level, higher level to lower level. For example, falls, rivers. They will flow from one place to another. Keep on moving. The molecules has a capacity to move. What it indicates, intermolecular distances are not too much tight. Means they can move. But what about the gas? For liquid we call it as the flowing. Water is flowing. Gas, there is no intermolecular force of attraction at all. All the molecules are free. They are free enough. They keep on moving. Means one room is there means everywhere. For example, one solid piece of chalk is there means I will keep here only means here only. It will stay here only. What about liquid? Yes, it will flow from here to here. That's it. But what about the gas? It will occupy the whole container. Container means room. Everywhere air is there. It is possible to say here air is there. There is no air. It is possible to say like that? Nothing. Because it's free to move. It's keep on moving. There is no force of attraction between one molecule and another molecule. Simply we call it as the force of attraction is very negligible. Here gas molecules are very free to move. No shape, nothing. No volume. It occupies the whole container. We can't hold as it is. If it is inside the cylinder, we can hold. Once if you open that, we can't hold the gas. Yes. Now, states of matter. States means anything which has mass and occupy some space or else volume. Types of matter. 3 types: solid, liquid, gas. Now you come to know the characteristic features of solid, liquid and gas. You also know one more important one. All the states of matters are interconvertible. States of matter are interconvertible. States of matters are interconvertible. Solid. We can convert the solid into liquid. We can convert the liquid into gas. But now the question, how? For example, I will give just one general example. Ice. Ice always exists in the form of solid. Ice cubes. Ice cube is there, solid is there. If I increase the temperature, what is the melting point of ice? Just 0 degree. If I just keep the ice normal ordinary room temperature, what happens? Ice will start melting. Once ice start melting, the solid is getting converted to liquid. Means if I give the temperature, solid is getting converted to liquid. Now liquid means what? Water. Now water is there now. This water, once again if I give the temperature in the form of heat, if I boil the water, what happens? Water is getting converted to gas. Now gas. Gas means what? Water vapors. The water vapors, I am start cooling that. If I cool the water vapors, then what happens? You will get the water droplets. For example, if you prepare any delicious food, then if you just open that plate, above that plate, below that plate, there is a collection of so many water molecules. Why? Because in hot conditions, the water exists in the gaseous state. When the temperature becomes cool or less, all the gas molecules are collected as water droplets. Means they start condensing. Then after that, once again I am still cooling that. The liquid water is there. Still I defreeze it. Refrigerator, if I use the refrigerator, if I defreeze that, what happens? The liquid is getting converted to solid ice. What it indicates? All the status of matter. I am not telling if in all the conditions condition, it's not possible. But in some cases, states of matters are interconvertible. Interconvertible means we can change from one state to another, and once again we can regain that original state also. Means all the states of matters are interconvertible. How we are going to deal these interconvertible states? By varying the temperature and pressure. Here cooling means what? We are applying the pressure and decreasing the temperature. That is cool. Now next one. Classification. Next one is a very important one. Classification. Why classification is very important for us? Without classification we can't study the matter. We can't. There is no exact boundary for solid, liquid, gas. Not only for this. Without knowing the actual thing, how it is possible to remember everything? So, classification is very important in order to understand the concept systematically. Here, matter we are going to classify into two types. Matter we are going to classify into two types. What are they? First one, mixture. First one, mixture, and second one, pure substance. Matter, I am going to classify into two types. First one is mixture and second one is pure substances. What is this mixture? Mixture means it's a collection, combination of two or more things. You know mixture, safe. Mixture you know. Means there is only one item is there? No. It's a combination of 2 to 3. It's nothing but mixture. Mixture of colors. Only one color is there means we call it as monochromatic. More than one color, it's nothing but mixture. Only one pebble is there means it's only one thing, pure one. But it contains two or more means it's a mixture. This one is one color, this is another colors, it's a mixture. Here once again mixture going to classify into two types. First one, homogeneous mixture. Homogeneous mixture. And second one, heterogeneous mixture. Mixture we are going to classify into once again two types. First one, homogeneous mixture, heterogeneous mixture. The name itself indicates homogeneous. Homo means same. Homo means same. What is this homogeneous mixture? Means I will give one general example first. In this beaker, I am going to take water. Inside the water, I am going to dissolve NaCl salt plus sugar and start stirring that. After some time, first water is there. I am going to add NaCl salt and sugar. I am keep on stirring that. what happened? Once if I start stirring, it start dissolving. It start dissolving. Then it look like a normal water. See, near one, you just keep one more beaker or glass of water. It's only water. H2O means water. Here, this is water. This one is water, salt plus sugar. It's a combination of three things. Water, salt, sugar. But it mainly contains only one thing, water. Now I will keep two glasses adjacent to each other or else nearby. Now, it is possible to differentiate these two? No, we can't. If I keep two bottles in front of you, if I say which one is mixture, which one is normal water, it is possible to, if I ask like that, it is possible to answer for the question? No, because both will appear as normal water. But if you take 1 spoon of water, taste it. It's water only. If you take this and taste it, it's nothing but salt plus sweet. You will experience the presence of sugar and salt. Means what? It's a mixture, but the mixture is homogeneous. Homogeneous means same. Means we can't differentiate. All the atoms, all the molecules are in uniform arrangement. Means here, all the atoms or molecules are uniform. Why I am using the word uniform? If you just take one sip or else 1 spoon of this liquid and taste it. Here more sweet, here more salt. It's like that? No. It's uniform. The concentrations is remain same throughout this. That's why I am using the word uniform. Means homogeneous mixture means what? It contains 2 or more substances, but it remains as uniform concentration. It remains uniformly. That is homogeneous mixture. What about heterogeneous mixture? Heterogeneous mixture means, I will give general example first. I am going to take 1 beaker, water. Now I am going to add 2 drops of oil. Now I am going to add 2 drops of oil. Then I am going to start stirring it. I just stir this. How much if I stir also, it's useless. Above the water, oil will float. Why? It forms immiscible liquids. Immiscible means within one liquid, another liquid, it never dissolves. It forms immiscible. Immiscible means within one liquid, another liquid, it won't dissolve. We can observe the 2 layers. We can easily identify through our naked eye, yes, this is water layer and this is oil layer. Means 2 layers, 2 bifurcations we can easily observe here. Means what is this? Heterogeneous mixture. Hetero means different. Hetero means different. Here the 2 layers are different. Not only this, one more. Take 1 beaker. Sand. Take sand. Add water. Add sawdust. What happened here? See, I am going to add 3 different components. Water, sand, sawdust. If I add water to the sand, sand will sink because of its mass and water remains as it is. Means inside the water we can easily absorb the sand. But sawdust, its mass is very less, density is very less. That's why it's keep on floating on the surface of the water. But we can absorb all the three: sand, water, sawdust. Means three different bifurcations. What it indicates? It's nothing but heterogeneous mixture. Matter we are going to classify into two types. First one, mixture, pure substances. Mixture, once again two types: homogeneous mixture, heterogeneous mixture. Homo means throughout the system it's uniform. The compositions are uniform. And this one, heterogeneous, means throughout the system the composition is not uniform. For example, I want sawdust here. It is possible? It's possible to get here? No, it's not possible. Because it's different. This component is different. This component is different. This component is entirely different. This is regarding mixtures and its types. Now, pure substance. Pure substance, once again we are going to classify into two types. What are they? Element, compound. Element, compound. What is this element? Pure substance. First you should understand pure substance means what? Pure substance means, for example I will give. I am going to take one iron rod. This is, just assume this is iron rod. This is iron rod. I am going to take one iron rod. See, I am going to cut here. Then I will test these portions. It's nothing but iron only. Now I am going to take this much portion and start examining that. That is also Fe. Iron, you know the symbol for iron. It's nothing but Fe. Here I am going to take this much portions. Last here I am going to take the iron piece. Everywhere, wherever you will take, if it is iron means, in middle, wherever you will take, it's iron only. Means pure substances. Here also, elements, compound. Element means, for example, hydrogen. For example, hydrogen gas. Element. Molecules. One more, hydrogen molecule. We are using the word hydrogen molecule. Only one hydrogen is there means we call it as atom, element. 118 elements. It's pure. Hydrogen means in hydrogen gas, wherever you will check, it's only H2, H2, H2. Wherever you check, it's nothing but H2. But in compound, it's not like that. It has its own perfect composition. For example, C6H12O6. What is this C6H12O6? It's nothing but glucose. Here only carbon? No. Along with the carbon, hydrogen is there. Along with hydrogen, oxygens are there. But the compositions are fixed. Only 6 carbon. Within one molecule. Only 6 carbon. Only 12 hydrogen. Only 6 oxygen. We can't write C5H12O6. It's entirely different. Another compound. Try to understand properly. Here, it's a combination of different types of atom. But the composition is very much fixed, clear. C6H12O6. For example, NH3. Ammonia. 1 nitrogen, 3 hydrogen. I can't say I don't like 1 nitrogen. I will use 3 hydrogen and 3 nitrogen and 1 hydrogen. This is nothing but ammonia. I can't say like that. Means the ratios are fixed, precise, unique. This is nothing but compound. But you just take this glucose. Everywhere you will get C6H12O6. Everywhere you will get C6H12O6. Ammonia, you will get everywhere NH3, NH3, NH3 only. It's pure only. It's not a mixture. But it contains different types of atoms in a different ratio. Now, one more interesting fact. You know water. How water molecule will form? H2 plus O2, we will get H2O. Correct? How water molecule will form? H2 plus O2, we will get H2O. Yes, it's not balanced. I am going to balance here. Correct? You know balanced chemical equation. In 10th, that was also one of the lesson. See, 4 hydrogen and 2 oxygen. 4 hydrogen, 2 oxygen. Is it balanced? No doubt about that. Now, the interesting fact. See, hydrogen, you know hydrogen is a gas. Hydrogen is a gas. In 10th, one experiment was there. Means, in order to identify the upcoming gas was hydrogen, you burn that gas with candle. Then what happened? You will hear the pop sound. Means in acid, for example, metal react with acid, one gas is released. Then in order to understand what type of gas, we did this experiment. Means we pass that gas through the soap bubbles. Like this experiment. See? This is soap solution. We pass here metal plus acid. I am going to pass. Once metal interacted with the acid, it starts liberating gas. I am going to pass this gas by using delivery tube. Why we call it as delivery tube? Because it delivers the gas from here to here. I am going to pass. Gas means you know we can't hold hydrogen, there is no aroma. If for example cylinder gas is leaking means we can easily identify because due to the presence of mercaptan. But here for hydrogen, for oxygen, it is possible to experience the aroma. No, for example, if oxygen is there means wow, what a pleasant aroma. Is possible to say like that? No, it's not possible. I am going to pass this gas by using delivery tube to the soap solutions. Within that soap solution, what happened? The gas will collect and it start bubbles. For this bubble, if I burn with candle, then suddenly it will blast and we will get the pop sound. You did this experiment in 10th. 10th you did this. Yes, here hydrogen is nothing but gas and it burns with pop sound. What about oxygen? Oxygen we all know it's very important for breathing purpose. Oxygen, this one also very important gas. And without oxygen, nothing will burn. It's very important or else supporter for combustion. We call it as supporter for combustion. You know, it's one experiment. Take one candle. Take one candle. First, normal. It's in room temperature, no? Room. What happened? It's keep on burning. Now, I am closing the glass invertedly. Invertedly means ulta. After some time, this flame is there, no? It will cut off. Why? Because inside this there is no oxygen, no O2. Means everywhere, in order to burn anything, we need oxygen. Without oxygen, we can't burn anything. Means oxygen is supportive for combustion, and hydrogen is a fuel. Hydrogen gas, fuel. One is supportive for combustion, one is fuel. But the combination we will get now, that is water, H2O. That water we are always using in order to suppress the flame. You know, everywhere. For example, if anywhere fire catches means suddenly we will call for fire engine. What they will bring? They will bring any gas, hydrogen gas, oxygen gas. They will bring water. Means it's a fire suppressor. Just try to understand. Before, hydrogen nature is different. Oxygen nature is entirely different. But once they combine with a specific ratio and it forms the new compound, the nature is entirely different. The nature is fire suppressor. Water. See the beauty of chemistry. For example, one oxygen is there means one more oxygen. If two oxygen will combine, we will get O2. Next important one, properties of matter. See next one, very important one, properties of matter. What is this properties of matter? Means for everything has its own property. Correct. For example, for human beings also, all are human beings only. But all are unique in their own ways. Thinking, talking styles, walking style, behavior, the way they are interaction, their views, their perceptions, everything are different. Here, properties of matter, there are two types of properties. First one, physical property. Physical properties. And second one, chemical properties. Yes. First one physical property and second one chemical property. What is this physical property? Physical property means without it changing the chemical things. For example, mass. Mass is there. I am going to chuck the mass. Means, for example, here 5 kg tomato is there. Means it remains as it is. I am giving general example. Here, physical property, density. Water density, it's always constant. If I check the density means Water will change. Water will convert it to some other compound? Nothing. Means physical property means without changing, without disturbing the chemical features, chemical combination, composition, what are all the things we are going to analyze, deals, measure, it belongs to physical property. For example, temperature. Temperature is nothing but physical property. We can increase the temperature or we can decrease the temperature. For example, I'm going to take water because it's easy to understand. I can increase the temperature. Then states of matter will change, but H2O remains H2O only. Means if I check the temperature, it's temperature only. It's just, it indicates the presence of hotness. How much hotness is there? Whether it is cold or hot. Degree we always measure this in degrees Celsius, Fahrenheit, Kelvin. Means physical property means without disturbing the chemical features. Without disturbing the chemical feature. What about the chemical property? Chemical property is very simple and easy to understand. For example, I'm going to take one metal or anything else. For example, I'm going to take one paper. For this paper, I start burn this, ignition. Then what happens? It start combustion. After that, can I get the same paper back? No. Means it's chemically changed. Now, metal is there. For this metal, I am going to add acid. Then also it remains metal only? No. It will change. Respect to acids, it will change. If I use HCl, it will get converted to metal chlorides. If I use sulfuric acid, metal sulfate. Means with respect to the acid, it keep on changing. Means what it indicates? It indicates chemical properties. Means it's nothing but properties. Here we are going to deal with the chemical change. Once a reaction proceeds, the properties are entirely different. See, before paper feature is entirely different. Once if I ignite that, then it is entirely different. Take normal rice, boil it. After boiling, we call it as boiled rice, but it's not normal rice. Anything you just take and ignite that, you will get the ash. Ash is not the, after that, how much you cool, how much you decrease the temperature, how much you increase the pressure. It is possible to get the original one? No. It is not at all possible. You all know one familiar one. Take one magnesium wire. Burn this in normal atmosphere. We will get white powder, that is magnesium oxide. But magnesium oxide is not magnesium. This one is entirely different and this one is entirely different. It's nothing but chemical change. Means acidity, basicity, these are all chemical properties. Mass, volume, temperature, these are all physical properties. Then measurement. What is this measurement? Measurement means what? Here measurement is very important one. For example, if you enter to any market, you want to purchase some vegetables. For example, tomato, onion. Then how you will ask, I want onion. The next question, the immediate next question one, how much you want? How much means 1 liter onion? It is possible to ask like that? No. Means what we will ask, I want 1 kg onion. Kg. What is this kg? It's nothing but measurement. Solid we are going to measure in some different units. Liquid some different unit. 1 liter. 1 liter milk. 1 liter oil. 1 liter coconut oil. Castor oil. Kerosene. 1 liter petrol. Diesel. 1 kg diesel? No. For everything has its own unit. Why these units are important? Why we want measurements? Without measurements, anything will goes wrong? Yes, obviously. If I ask, what is the length from here to here? Without a measurement, without knowing that, how it is possible to say from here to here, so and so many centimeters are there, so and so many meters are there. From Mysore to Bangalore, what about the distance? Means without measurements, how it is possible to say, how it is possible to find out the distance from one place to another place. Now, measurement, 2 types are there. First one, English metric system. Second one, first one, English system. What is this English system and metric system? Compared to this English system, we are going to deal with only metric system. In France, they gave certain ideas in order to measure the things. Means mass, length, how to measure. This is metric system. Now, in this, we are going to classify 7 major fundamental things. Fundamental means it's very important, is essential for us. Here we use the word SI unit. What is this SI unit? International system. The metric English system is there, no? Like that. International system. This international system means it's universally throughout the world. For example, distance we always measure in meter, centimeter, decimeter, kilometers. But it should be measured in meter only. Means it's fixed. Mass we always measure in kg. Means what it indicates? It indicates these are universally acceptable. Here only 7 basic fundamental things. Fundamental things means only 7 we are listing. Within that we are going to derive some other. For example, for distance unit is there. For speed we are going to derive from distance. Yes. Now, first one, length. second one mass, third one time, fourth one electric current, fifth one temperature, sixth one amount of substances, and last one luminous intensity. Here there are total 7 basic fundamental systems. First one, length. Length always we use the word L. Length means what? For example, I want distance from here to here. Length. How much length is there from here to here? It may be in centimeter, it may be in meter, it may be in kilometer. I don't know. Length. Mass. For example, here some amount of substances are there. What is the mass? Then mass always represented by the letter small letter m. And next one, time. What's the time? 10 o'clock, 11 o'clock, 12 o'clock. Time means small letter t. Electric current. For example, here current is there means voltage is not enough. You'll always use the words voltage, ampere, currents. Here current is always represented by the letter I. Temperature, capital T. Temperature means what? It's nothing but measure of hotness. Measure of hotness means whether it is too hot or too cold. Both are temperature. But one is high, one is low. It is always capital T times small letter t. And amount of substances. See here total mass. But amount of substances means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's represented by the letter N. Amount of substances means within the substances how much elements, atom, quantity. That is amount of substances. Luminous intensity. We use this word especially in order to measure the brightness of sun, stars, moon. Means you know celestial bodies has its own light. Sun means has its own light. Moon doesn't have any own light. But in order to identify the light intensity, its temperature, we are going to use the word luminous intensity. Luminous means glowing, brightness. And what are all the units we are using? The SI units. SI means international system. SI means international system of measurement. System of measurement. International system of measurement. SI unit means international system of measurement. Length, mass, time, electric current, temperature, amount of substance, luminous intensity. Length we always measure it using as a letter L. Mass small letter m. Time small letter t. Electric current capital I. Temperature T. Amount of substances N. Luminous intensity IV. Now what about the unit for length? Meter. For example, from here to here distance, just I am giving the example, 10 meter, 5 meter, 20 meter, 30 meter, and mass. It's always in kg. 1 kg, 2 kg, 3 kg, 10 kg. Time always we measure in second. We can also measure in hours, minutes, but we are talking about international system of measurement. Next, electric current, ampere. Ampere, name of the scientist. Then temperature, we always use Kelvin. Kelvin also name of the scientist. Amount of substance is mole. Luminous intensity, candela. Luminous intensity we always measure in candela. It is nothing but CD. Candela. Means length always measure in meter. Mass always in kilogram. We call it as kg. Time in seconds. Electric current in ampere. Temperature Kelvin. Amount of substance mole. And last but not the least, candela for luminous intensity. Here one thing you should know. There are 7 basic fundamental units. But remaining things are derived one. For density is not the fundamental one. Density we know the formula, mass by volume. Mass means it's a basic thing. What is the mass? Kg. Volume, here volume is not the fundamental one, but volume is nothing but length into breadth into height. Length always measure in meter, height, breadth, everything measure in meter. So kg per meter cube. Got it? This is derived one. We call it as derived one. Means in nature only 7 basic fundamental units for measurements. These are so and so. But remind what are all the things? Velocity, speeds, acceleration. These are all derived ones. So in this session we learn so many things. Matter, states of matter, the properties of states of matter and their classifications and measurements, physical properties, chemical properties, difference between physical property and chemical properties. These are all the basic concepts in chemistry. In next class, so many laws and so many significant figures, everything we will discuss. So, you have any doubts regarding this? Just pose the questions. Thank you so much.